Alrighty, let's do this. So it's going to be some game, medium. Alice and Bob take turns playing game. Alice starts first. You're given a string num of even length and consisting of digits and a question mark characters. On each turn, a player will do the following if there is at least one question in nums. Choose an index I where nums I equals question mark, so choose a question mark. Replace nums I with a digit between 0 and 9. Game ends when there are no more question mark characters in num. For Bob to win, the sum of the digits in the first half of num must equal to the sum of the digits in the second half. For Alice to win, the sums must not be equal. Okay. For example, so it has to be an even length. Okay, yeah. 2, 4, 3, 8, 0, 1. So there's no question marks. 2, 4, 3 adds up to 9. Adds to 9. Bob wins because 9 equals 9. If the game ended with 9 equals 11, then Alice wins. Assuming Alice and Bob plays optimally, return true if Alice will win, false if Bob will win. Okay. So num, pretty long length. Okay, 10 to the 5th. How to do this. So at any given point on any given turn, let's say difference, diff, which equals the difference between first and second half. Is some value. Let's say it's D, or let's say it's X, I guess. Let's say it's D. D equals difference. So Bob would need to so it has to be true that Bob has the last move, I want to say. Right? Because if Alice has the last move, then there's no way that Bob there, and like Alice has always some possible thing to make it not equal. So Bob needs to play last in order to win. Alice always wins if last player. So I think that means the number of question marks needs to be even, right? Because the first question mark is Alice playing it. I wonder if that was one of the conditions. No, well, one of the constraints, but what else is going to happen? I mean, I think so if the question mark is, if difference is the actual sum of the first half minus sum of the second half, then what would happen if the question marks only occur in one half? if the question marks only occur in one half, then let's say there's only question marks in the second half. So it's like the difference is 27 here. Well, here, I guess it needs to be an even number of question marks in order for this to be relevant. So Bob would try to reduce it to 0. Alice would try to keep it at as big as possible. So Alice would do zeros, and Bob would do 9, and then Alice would win. Is it possible to simplify it by removing the number of question marks in both halves? Like if there's a question mark in the first half and a question mark in the second half, can I safely assume that those are going to be negated somehow? Does that work? Because in theory, if Alice makes the first half question mark something, then Bob can always make the second half question mark something as well, the same thing, to balance it out. If it's already unbalanced, let's say there was like 9 question, 1 question. So it's already unbalanced in favor of the first half. Alice would just keep the imbalance by making the largest number in the bigger half. So Alice would do the first question mark into a 9, make that 18 on the first half sum, and then Bob can't do anything. So Alice always has the upper hand. I want to say the question marks on either side of the middle. My intuition is that question on either side, on question appearing in both kind of cancel each other out. Which means that Alice stays. Alice stays advantaged unless I guess that means maybe that Alice stays advantaged unless is or even on both sides, like it's 3 question, then here Bob would win because whatever Alice would do there, Bob can answer. So if it's unbalanced, if it starts unbalanced, then Alice would win. If it starts balanced, then Bob would win, assuming there's the same number of question marks on both sides. And so now it's just if there's an uneven amount on both sides of question marks. So it's uneven number of question marks, but there are still an even number of question marks. Like there's an uneven split of question marks in the first and second half, but the total number of question marks is still even. In that case, what happens? Let's do 9 question, or I guess I need like maybe 9 question. I need 2 question marks here, and then 4 question marks there. What would happen here? I think in this scenario, Alice probably wins, because Alice gets 3 shots here. Alice could make this thing into a 9, which makes this into a 27. Maybe if Bob makes the other one to a 0, makes this second question mark into a 0. Yeah, Alice wins here, doesn't she? Because if she starts by making this a 9, that makes it 27. So it's going to be at least 27 here, and then she can make 2 of these into 0, so it can be at most 18 in the second half. So can I just say that it's equivalent to doing something like this? I mean, this is the most simplified version of this, because I can't do 1 and 2, 1 question mark, 2 question marks on the first and second halves. It has to be 2 and 4. Is there any way that Bob wins here? Feels like this might be a Bob win. Okay, let's say this one. This one I know Alice wins. First half is going to be at least 27. Second half is at most 18. So if it's 2 zeros, 2 question marks, I think this is a Bob win. Like in theory, if this was 0 0 question mark, Bob wins, right? No, Bob loses. What the fuck? And does this mean Alice wins here? I can't just reduce the question marks, I don't think. Alice, what happens here? I mean, the first half is going to be pretty small. So, yeah, Alice wins here. Alice makes the first. This should be identical to this thing, kind of. Alice makes the first half really small, because the first half can be at most 9. If Alice makes one of the question marks 0, Bob can make it 9, the second question mark. And then Alice has the second half is going to be at least 18. Alice can put 2 9s in the second half question marks. Okay, so it could be that it's possible that the simplification is removing the question marks on both halves, but there has to be a way. There has to be a way that Bob wins here, no? What if it's 9-0? Because here the simplification of, or let's say, if it's 9-0 question, I think Bob wins this for sure, right? Alice makes any number, Bob makes a complement number. But the only sum that works here is like something that adds up to 9 here. So it could be 1-8, could be 2-7, 4-5. Okay, interesting. Interesting. So it's some sort of complementary deal. Every pair of digits needs to kind of add up to 9 in some fashion. But then does this work? Yeah, so if this was like 18, right? If it was like 9090, I think Bob wins here. Pretty sure. Because then if like Alice does 1, Bob does 8, Alice does 2, Bob does 7. Okay, interesting. So, so it's like a reduction. It's a reduction to cause pairwise addition to 9. A reduction to cause pairwise addition to 9. I guess I really want to know whether or not this is Bob wins. Yeah, it does, right? Because whatever Alice does in any of these two question marks, Bob does the complementary to add up to 9. And then and then similarly, any of these question marks, Bob wins. Yeah, okay, so I guess if this was something that was anything that did not add up to 9, so let's say it's 4-1, I'm assuming this must be Alice. 4-1 is 5. So Alice sees that the first half is small. So she'll make, what can she do? So she sees that the first half is kind of small. Well, adds the 5. So if she does 0, 0, then Bob can do 9. That gives 14. And then she does 9-9 in the back half. So here I think Alice wins. Like she minimizes the minimize first half, maximize second half, and it should be unequal at that point. And even if it was something that was even, can this be wrong? Let's say it was really close to, yeah. She still minimize this thing. She'd make this into 17 the first half. And then she would make she'd make it 17 the first half, and then the second half would be at least, well, so she puts down a 0. Bob puts down a 9, so 17. Yeah. Then she puts down 2 nines. I think that's it then. I don't think there's any other cases really. Well, if there's some number of summation, then is it just a difference? So if it was something where, let's say it's 4, 4, question, 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 what happens here? I think I just care about the difference. Yeah, I think I just care about the difference. Okay. So let's just parse this real quickly. Let's say n is the length of num. And let's say total 1 and total 2 are the half totals. So for every value in nums up to the first half, and if the value doesn't equal the question mark, total 1 plus equals the integer of the value. And I think I need to have the count of the number of question marks. I'll do qnum and qnum2. Okay. For every value in nums from the second half on, add this to the total, else add to the count, and then I'm just go ahead and print this out to make sure it's correct. Returns true if Alice wins, is that right? And if this parses it correctly, so 5 is the sum of the first half, 5 is the sum of the second half, 0 is the number of question marks in the first and second half, 7, 0, 0, and 2. Okay, yeah. So I only care about the difference, and whether or not the difference is a multiple of 9, I guess. Actually, let's do the trivial case. Alice wins if odd number of question marks, or yeah, I guess it, yeah. Return if qnum1 plus qnum2 is odd, remainder of that divided by 2 is 1. Okay, so that's the trivial case. And then if it's an even number, actually, did I solve all the even cases? What if there's 1 and 3? What if it's like 9, question 3? Actually, I didn't solve this, huh? I feel like here Alice would win, right? Because Alice would do 9 in the first half. Or did I do this? I assume this has to be Alice wins. I assume this has to be Alice wins. Because Alice would control whether or not the half that she's dealing with is going to be bigger or smaller. Yeah, I'm pretty sure. Like, is there ever a case where if it's a 1-3 split, Alice loses? Like if it's 0-0, Alice would make a 0 in the first half. 9-9, Alice makes a 9 in the first half. If it's like 9-0, Alice makes like... Actually, maybe Alice loses here. Maybe Alice loses here. Because if Alice makes a 0, then Bob makes a 0 in the second half. Alice makes a 9, Bob makes a 9 in the second half. Yeah. Alice loses here. Maybe this is just a simplification of removing the canceling a question mark. Yeah, I think it's a simplification of canceling a question mark. So I think it's like, so if it's like 4-1 question mark, Alice wins because Alice makes the first half into something small, 4-1-0. Yeah. So if the number of question marks is uneven, it reduces. I think the thing that is of concern is whether or not the difference is a multiple of 9. I think that's the only thing that matters. Because at this point, it's just a multiple of 9 deal. Return true. Return if total 1 minus total 2 is divisible by 9. um, Why isn't this true? Or this is false. What? Alice wins if they're uneven. Oh, right. I guess Alice wins if they're uneven. Bob is the one that wants to make it even. So, yeah, so did I just screw up the logic there? Yeah, but they start out even, and Alice doesn't win. Yeah, okay. Gosh damn it. All right. I mean, got to 83 out of 95 test cases. Okay. Let's print out the total 1, total 2, unum 1, unum 2. Print the difference. Oh, I need to do the test case. Three nine six. So I said this is false, but it's true that Alice can win. 3 4 1 3 6 7. 3 4 1 3 6 7. Oh, how many? How many is that? 26. I wonder. There must be some sort of logic that I'm missing here, obviously. So the first half is bigger, and the second half is smaller. So I would assume that Alice would try to pump up the first half as much as possible. So, I mean, there's a natural. So I think Alice should win here. Yeah, Alice should win here. But somehow I thought that Bob would win here. So Alice should make the first half really big. And then Alice should make the second half really small. Alice should win here. Maybe I just guessed this logic. It has to be comparable to 9. 26. Yeah, yeah, my logic is not thinking about this correct. If it's a multiple of 9s, if it's possible that still doesn't work, right? Because it could be something like this. Like even if it's a multiple of 9, it's still not here. I think I think this test case is something I do wrong. Pretty sure. Yeah. I need to do slightly better logic. There needs to be some upper bound into the catch up. I wonder how it got to so many test cases without getting to this issue. 83 test cases, 82 test cases. So it has to be specifically a multiple of 9 and also within reach, I want to say. Okay. So if the first half, I guess if it's not a multiple of 9, then I think Alice would win. Yeah, if it's not a multiple of 9, Alice has to win, I think. But then if it is a multiple of 9, then whichever side has more like more left over. So it's not a multiple of 9. So the number of multiple of 9s must correspond to like the number of pairs of question marks on the other side. So if total 1 is greater than total 2, so that's heavier on the first side, then the number of excess question marks has to be on the second side. And the number of excess question marks has to be equal to like the multiple of 9 it is. So like qnum minus q2 minus q, the count times 9 has to equal the difference. Similarly, if the second is bigger than the first sum, and there's more question marks in the second half. No, in the first half. I guess I can just, I wonder if I can just do this, just do that. Yeah, I think that might be it. Because that incorporates both parts. There's more in the second half. And the more in the second half times 9 equals the difference. Does this work for if the first half is bigger? If the first half is bigger than this negative difference, I think that's it. Fuck. Well, I guess I should probably say I guess rather than I think. Three, two, 3295. Okay. This is one of the basic test cases. Can be proven that Bob will always win. 3295. So adds up to 14 versus 5. So the difference is 9. So it's 9 and a question mark in the first half versus 3 question marks in the second half. Nine and a question mark in the first half versus oh, I think I need to have done divide by 2. Whoops. Yeah, the difference in the number of question marks divided by 2. I think so. It's like, yeah, because this 3 minus 1 is 2. 2 divided by 2 is 1. 1 times 9 is 9. Okay. Okay. So I think this should just be, I guess I can combine these two cases if I want to make this into one if statement, but whatever. So I think I can just return this thing. Return without the evaluation this thing, since this is equals false, or return false, then just return the opposite. I could combine these two. Um, let's see. So Alice Bob wins. Yeah. Okay. Yeah. Syntax. Return whether or not. Okay. Sure. No need for colons. Okay. Pretty sure there could be something slightly faster, maybe in the parsing of it. Something faster, maybe in the parsing of it. But this is pretty straightforward in terms of what's happening, so just keep it. Okay, so here summary. This is I consider this to be more of a math problem rather than a coding problem, since the optimal way of solving this has very little to do with kind of coding slash kind of DFA stuff. Or is it DFA or DSA? Data structures or coding stuff. The simplification of who wins and loses comes down to a few different kind of scenarios, like cases. If question marks, if number of question marks is odd, Alice always wins. That's just by logic. Alice has the last move there, and they should always be able to make it uneven. And then what was the other one? Alice wins if the split is not already multiple. I guess this is kind of the trivial case. Other cases revolve around whether how do you spell whether? Oh my god, I blanked out. How do you spell whether? Whether or not kind of sum of digits is multiple of 9. In general, if it is, then Alice, then Bob can do the complement of Alice's move. Bob does 9 minus Alice, basically, in order to keep the balance and win at the end. If this cannot be done, Alice wins. So that's the main logic, and I did a bunch of test cases to figure that out. So if it always starts out split up so that it's not a multiple of 9 as difference of the two halves, then Alice will eventually win because Alice can maintain that uneven split. If it is a multiple of 9, then basically the number of moves that each of them makes, if that number of moves is times 9 is equal to that difference, then Bob can create that matching difference. So like this is just the count of the number of moves that each of them makes, which is the difference between the number of moves in the first half and the number of moves in the second half. Those kind of counteract each other. So divide by 2 is going to be the number of moves that like Bob makes, or Alice makes. Yeah, Alice and Bob makes some number of 9s, and that number of 9s needs to match the difference total. Time complexity, this can be O of n, where n is the length of the string, because it does the single parsing of it. Single path to count question marks and calculate thumbs of the first and second halves, and then space like this of 1 to yeah, since no space is needed, no arrays or anything. Okay,